Hi to everyone. Today we are going to discuss the topic is trees. When you come to the tree, we see the tree in the nature. So this is a view of the tree. The tree has a root, okay, next to branches, next to leaves. So now we learn this tree scientifically. So when you come to scientifically, you just reverse the tree. This is a tree which are you reversed, nature's tree. So now, when you come to this one, it has a root, branches, okay, leaves, and you learn here one more word is a node. In the computer terminology, you will learn one more word is a node. So now, we'll discuss all this detailing. First, we'll come to the definition of the tree, okay. So now, when you come to the definition of the tree, a tree is a connected undirected graph with no simple circuits, no multiple edges, no loops. So these are all connected simple circuit multiple edges we discussed it in the previous class, but I revise. Why? Because we need on the tree this all thing. So connected graph. First we'll come to the connected. So connected means every pair of vertices, every pair of vertices, there is a path. In a graph, if you take every pair of every pair of vertices, there is a path. So then the graph is called as a connected. So tree want to be satisfied connected definition. And second, it want to be undirected graph. Next, third, no simple circuits. So for example, this is one circuit, A, B, C. This is a one circuit. Or you can take this is a one circuit, A, B, C, D. That means a circuit is nothing but a circuit is a path which is a which starting and ending vertex are same. So that means the tree does not want to be contain these type of circuits. So no simple circuits. Tree does not want to be contains the no circuits. So what is the meaning of simple means? Simple circuit means uh, it takes no edge takes more than once. Simple means no edge takes more than once. Okay. So you have to remember a tree does not contain the circuits. Next, no multiple edges. For example, A is a one vertex, B is a one vertex, this is a one edge, and this is a one edge. So these type multiple edges are not allowed. Okay. Loops. Uh, Loop means, for example, A is a one vertex is there. One edge is started and ending at A only. This is a one loop. Okay, this is here some B vertex. There is a one edge which is started and ending at. Starting and ending points are the same for a single edge here. So no circuits, no multiple edges, no loops. So then that graph is called as a tree. So a tree is a connected undirected graph with no simple circuits, no multiple edges, no loops. So connected every pair of vertices there is a path. This want to be satisfied. Undirected, no simple circuit means the tree does not contain this type of circuits. Multiple edges is does not allow the multiple edges like this loops. Loops also not allowed. So this loop means it's a closed one. You just think that circuit and loops are the just a closed one. Okay. So closed one is not allowed in the trees. Next, in another way, definition, an undirected graph is a tree if and only if there is a unique simple path between any of two its vertices. This is a very simple definition compared to first one. So what is saying means an undirected graph. For example, I'm taking this one graph A, B, C. Okay, here some A, B, C, D, E. So now, what is the definition? Undirected graph is to find only if there is a unique simple path. For example, I'm taking A, D. I can move. Is there path A to D? Yes, A to B, B to D. There is a path from. There is a path between pair of vertices A and D. So now, what is saying unique path? To go A to D, is there any other path? No, compulsory I want to be from A to B, next to B to D. So unique path. Next, simple path. Simple path means when you go from uh, A to D, when you go from A to D, are you traveling any edges, same edge more than once? For example, I am going A to B, next to B to D. This edge traveling one time, this edge traveling one time. That means a simple path. Simple path. Simple means it takes edge only once, not more than once. You have to remember wherever you will get the simple circuit, simple path means edge takes only once. So now check it is all satisfying. So it is undirected graph. Unique simple path. First will come path. A to D. Is there a path? Is there? Is this unique? Yes. Why? Because I want to be. I can go A to B, B to D only. There is no other path to go A to D. Only one path is there. So therefore, unique path. Simple. Simple means when I'm traveling from A to D, I'm traveling each edge once only. When travel each edge once, then that path is called as a simple path. Not only A to D, you can take anyone. A to C. A to C path is there. A to E path is there. So all are the simple and unique path. If I want to go from A to E, how many path, different paths? Only one path is there. A to B, B to E. Only one path. So unique path. Okay. Simple. When you have simple path is saying simple means when I want to be go from A to E, I'm traveling A to B, B to E. So each edge traveling once only. Therefore, it is a simple path. Like this, we can discuss about the definition of the tree. Next, examples of tree. Now we'll see the example of tree. Is it a tree? Now you have to check is it a tree or not. So if you want to check is it a tree or not, you remember that is there any closed circuits or loops? Closed one is there. I have to check. Okay. Next is there is a path between every pair of vertices that you have to check. Is there any closed loop, closed circuit? No. Next, you can go from any vertex to any vertex. I can go from A to C. I can go for A to E, B to F. I can go. There is a path between every pair of vertices. Therefore, it is a tree. Next, this one. Is there any closed circuits? Sorry, is there any circuit? Circuit means itself a closed one. Circuit means a closed one. Is there any circuit? No. Is the path between every pair of vertices? Yes. E to B, B to D, A to D, D to C. For example, I want to go from A to C. I can go A to D, D to B, D to C. So every pair of vertices, there is a path is there. So connected. No circuits. Therefore, it is a tree. Okay. So now this one is it a tree? Yes, this is also tree. So you don't say this is a closed one. Closed means it want to be in between vertices. Okay, here no vertex is there. Okay, this is also tree. For example, three vertices is there A, B, C, A, B, C. This is called closed. Okay, the closed one is about the vertices. Okay, so don't think this is a closed one. So these are the examples of tree. Next, we will see which are the not trees. When you come to the first one, is it a tree? We will check. Uh, if I can go from A to D, D to E, E to B, B to E. It has a one circuit. It has a one circuit. Therefore, no tree. It is a not a tree. So that is calling cycle. Next, here, is it a tree or not? Is there any circuit? No, no circuit. But what is happening? But what is happening means when you go from, I want to be go from C to B, is there is a path? C to E. I cannot travel C to B. Therefore, there is no path between every pair of vertices, means is not connected. Therefore, it is not a tree. So first one, it has a circuit. So what is a tree? No circuits, but here circuit is there, therefore it is not a tree. Next, this one, no circuit. Here not, circuits is not there. But what is happening? If I want to be travel C to B, there is a no path is there. C to E, I cannot move further. Therefore, it is not connected. Therefore, it is also not tree. So these are the examples of not tree. Next, is asking where which of the following graphs are trees. First one, is it a tree? We check it is as a circuit. A to D, D to B, B to E, next E to A. So there is a circuit is there. Starting and ending vertex are same for the path. Therefore, not a tree. One more time, if you want. Uh, tree means first you check it has any circuit. Circuit means a path which starting and ending vertex is same. So for example, I am traveling from A, starting from A to D, D to B, next B to E, next E to A. Is there no? Therefore, it is not a tree. It has a circuit. Next, come to this one. Is it a tree? Is there any circuit? No. Is there path between every pair of vertices? Yes, I can move from C. I can move for C to E, C to A to E. I can move for C to D, C to A to E to B, B to D. Therefore, it is a tree. Next, this one. Is it a tree? Is there any circuit? No. Path between every pair of vertices. It is a tree. This one, it is also a tree. No circuit. There is no any circuit. Therefore, it is a tree. Okay. So these are all our trees. Next, uh, just now we discussed example only. Next, we'll come to the rooted tree. So what is a rooted tree means? First we'll come to definition. A rooted tree is a tree in which one of the vertex has been designated. One of the vertex has been designated as a root and every edge is directed away from the root. So to understand this, for example, there is a one vertex A, next B, C, next D, some E. So now, is it a tree? Yes. No circuit. Every pair of vertices, there is a path will be there. I can move from A to E. I can move for A to E, A to B, B to E. I can move for A to D, A to B, B to D. I can move for A to C also. So I can move from B to C also, B to A to C. Therefore, it is a tree. So for this tree, one vertex designated as a root. One vertex means, for example, not only so you have to take this as a root. This A as a root. So if A as a root and every edge is directed away, away means it is like a outside. They are outside of the vertex. Their edge is directed away. Away means they are coming like outwards from this A to B, B to D. Okay, next A to B, B to E, A to C. So the edges are directed away. They are going away. So therefore, this is called as a rooted tree. One more time, in the given graph, one vertex designated as a root. So here A is a root, all edges are directed away. They are like a going outward, directed away. So these type of trees are called as a rooted trees. Okay. Now next, it is not need. When you come to this one, if V is a vertex in the rooted tree, other than the root, the parent of V is a unique vertex U such that there is a directed edge from U to V. So what is saying means, for example, A